Presentation, we are going to go through in detail of the data set and the codes we did. So firstly, this is an introduction of what document intelligence is and the data set we used. First, we load and explore the data set, so all the packages we used, pandas, and then we used the vectorizer and we used train test split. So first we loaded the data set and we just saw what it entails, the column names and the entries inside the data set. So overview, we found there are 55,000 patient records and a mix of structured and unstructured data, which is perfect for document intelligence processing. And then we validated the data set to make sure all the columns were in place and they were all the required columns that we needed to analyze it further.
Cool. Yeah, so then we started by testing out some text extraction. So we used code, sorry, some notes here. Yeah, so we do just a very basic text extraction in this first step, where we scan through the medical condition information and pull it out of the data. And then we basically get kind of just a list there of the different medical condition types. It's very easy, it's very simple extraction. And then we proceed to use a summarization. We proceed to do a summarization using just a frequency-based approach. So we start off in this section by doing just a quick sentence extraction based off of punctuation. We do a word frequency calculation to look at the frequency of words in each across the text. And then we rank the sentences. And based on that, we can kind of associate the medical summary data with each document that we've chunked out. And this is actually just a very easy, lightweight approach to pull out the relevant data from the text. If we want to get into a more in-depth summarization technique, we can use a pre-trained model like BART here. BART stands for bidirectional autoregressive transformers. Basically, it's 50% like a BERT model paired with a autoregressive decoder like a GPT. So for this, we install the pre-trained model from Hugging Face. We do a quick text pre-processing step to check the length and make sure that the text isn't too short. And then we implement the model to do the summarization. We pass it the text, and then it will start looping through and producing summaries of the text. And basically, we get almost exactly what we expect. We get for our data is relatively short, so we get exactly cancer or diabetes, kind of one-word brief summarizations. For longer entries, we would probably receive a bit more coherent or context-aware output as a form of summary. Usually BART's very good for model-based summarization and providing insightful and accurate summaries. And it's much more applicable for handling complex sentences compared to frequency-based methods, which can be a bit more rigid and inflexible. For our case here, the short text, it didn't perform too well, kind of just returned them as is. But in general, the pre-trained models, even though they work slower, they're just more valuable in terms of the output. Um, Going forward, we can improve by skipping shorter segments. We could fine tune and actually train the BART model rather than downloading the pre-built or pre-trained model. So it's more focused on healthcare data. And then we could also parallelize and use batching to improve time if we had a larger data set and more complex data.
Okay. And next we went on with the named entity recognition using regex. So is used on structured data sets, and it's very simple and it's very limited to only structured data sets. So for this one, we focused on three columns: medical condition, date of admission, and billing amount. So each column analyzed specific patterns and extracted that specific word number related to that column. So we have the code written down here. Um, and then for our output, you can see that with the rejects, we're able to get the date as an actual date format and the monetary amounts, which is the billing amount. And then for proper nouns, they identified the medical conditions like cancer, obesity, diabetes, and cancer as a proper noun. The only, but it won't be able to differentiate a disease and a medication. So that's when we use SPACY, which is more advanced in identifying the specific categories of entities. So for SPACY, we also decided to combine two of the columns, medical conditions and medications. And we loaded on the data and used the SPACY library. We had to install it first, and then loaded the library in. And this is the codes that we used. And it's computationally a lot, so it did take some time, as you can see, with getting the right amount of data. But this was the output we got. So a condition labeled as obesity and medication is ibuprofen, and it identified ibuprofen as an org, like as a product or a brand. But it could also identify patient names, but we're not able to see that in the specific data set because we only analyze two specific columns, medical condition and medication. With SPACY, though, it's limited because it's not able to use it for healthcare data sets. The basic model, it's not trained for medical terminology, so it can be a bit strenuous to identify like aspirin from cancer or even other important entities will be missed. But SPACY is efficient for large data sets and it is flexible, but it would just need to be tuned for the medical domain. And next we did the text classification. Text classification, we categorize the medical conditions based on their admission type, if they were emergency, elective, or urgent. So we did a basic approach first, which is a count vectorizer. So count vectorizer, it categorizes the text data and it doesn't add weightage to the word or takes into the word account for the context as a whole or surrounding sentences. So if a word is generic, for example, it would see the word urgent as a generic word, but as a human, we would know urgent is urgent, but it won't be able to recognize that weightage of that word urgent. So that's when we decided to go in and use the TF vectorizer. So TF vectorizer, it adds the importance to those words. So it would be able to recognize emergency as an emergency or urgent as it's urgent. And it's also really good with domain specific. For example, if it's a healthcare data set, then it's able to analyze those healthcare words. And if we're using a financial document, then it's able to analyze those financial words. So this is the code breakdown of what we did for the TF vectorizer. And so we did a matrix, and you can see here that the accuracy is 33%, which is not perfect, but it's probably due to we need to do more pre-processing in the data set, and there are probably imbalances. But you can see with like the F1 score, precision and recall, the admission types and how much value they have, elective, emergency, and urgent. Um, but going further, you can see that the document, if it had diabetes, aspirin inconclusive, the admission type is urgent. And if it was document asthma, penicillin inconclusive, admission type is elective. So this summary output is different than going back above to the count vectorizer. It's very simple, not as detailed. So you would just get the diabetes summary and it would just be urgent. So count the TF vectorizer is more efficient for large scale data sets and provides more of a summary.
Yeah, and then finally we created our own custom data to go into and test out some of these methods following the count vectorizer and TF IDF vectorizer to show some of the versatility of the approach using a more complex data set text-wise. So we produced these kind of longer form sentences and then labels for each of them that can be either healthcare, legal, finance, as ways to test out the classification here. Then that's kind of the code implementation. And then below we see kind of some of the outputs. We have the kind of full sentence and then the predicted classification. And then again, we have the matrix of results for finance, healthcare, or legal. And we see kind of differing results across the three, which is interesting. And again, kind of a lower accuracy. So we got a little bit of mixed results on this. It very successfully predicted finance for instances that had closely aligned with finance language, but it struggled a bit more with legal and healthcare categories, and often declared those as finance instead. Yeah, see some of the more data there. So the precision in general for finance was low, but it did achieve full recall, while healthcare had a better balance between both precision and recall. But legal had no true positives, and its precision and recall were zero. This seems to be a problem with some of the overlapping vocabulary in the data. And really kind of just an insufficient amount of distinct legal terms, and to a lesser degree healthcare terms in the training data. However, the TF-IDF representation seemed to capture, or should capture better than count vectorizer. It didn't really differentiate too closely between terms across classes. So improving the data set in terms of diversity and better balancing different features could really improve this model. So in summary, we tested out text extraction. We successfully extracted text from the datasets, initial healthcare datasets, medical condition column, column validation, handled errors, and this was a very easy first step. For text summarization, we tested both a frequency-based summarization approach and a model-based approach using the pre-built Hugging Face BART model. The frequency-based method in this case provided very concise outputs for single word entries, but really struggled with context and larger texts. The BART model is very good at summarizing complex and multi-sentence entries, but wasn't fine-tuned for healthcare specific data, but tends to be more flexible in general. We did named entity recognition using regex for simple entity extraction. We did this just by identifying proper nouns and monetary amounts, and that worked very effectively. However, once again, while this method is very efficient, it lacks the ability to really discern context or very specifically dig into healthcare specific data. The more advanced pre-built spacey terms could improve categorization, but again, the one we used here wasn't trained for healthcare data. We did some text classification. We demonstrated good classification of medical conditions by admission type using both naive Bayes and TF-IDF features. Broader general data set was used to classify documents into either healthcare, legal, or finance categories. And despite improvements from the TF-IDF vectorizer, the model showed pretty heavy bias towards labeling things as finance. We think this is due primarily to overlapping terms and insufficient data features for the legal or healthcare categories. And finally, we think enhancing the data set diversity and introducing more terms for those other categories would greatly improve the model accuracy and performance.
And that's the end. Thank you.
Okay. Is that good?